Hey, welcome to a code walkthrough of training Cypher 10 with PyTorch. The PyTorch is a machine learning framework that is used for training deep learning networks, and I will be using my variant of TorchSwarm. So this is a implementation that is written by me, and it contains the rotated EM particle sum optimizer, which is nothing but the rotated variant of the EM PSO from the paper. So if you look at the right, you will see two methods which are very important methods. So one is the CE loss and the CE loss with PSO. So the CE loss is one that is being used by the rotated particle sum optimizer to calculate the loss between Y predicted and your particles, which will be later used to get the best G best. And the CE loss with PSO, this is the loss that is going to be used in TorchSwarm so that you can remove the auto gradient part of your back propagation and replace it with the approximation that we have done. Now coming to the code, to the AdaSwarm code. So here you can see that it uses GPU. So if GPU is available and you have a GPU that is supported in your system and you have the CUDA installations that are required, then it works with that. So here you will see that you have four variables, and in that these two are the most important ones. So that one is the batch size and the other is the swarm size. So batch size is nothing but dividing your data set into n number of batches so that your training becomes easier. You don't force 7,000 records directly into your model, but you break it into 125 so that it's faster. And swarm size is nothing but the number of particles in your swarm. So if you say if here it is 100, so that means my RMPSO is going to run with 100 particles. Now coming to the data, this is nothing but just creating the data, normalizing the data based on some factors, and this is a very common method in deep learning to normalize your data set before you pass it to the model. And along with that, here you are creating your train set, your train loaders. These are nothing but generators that will generate batch sizes of 125, and it will also shuffle on the fly. Similarly for the test set. Now coming to the classes, Cypher 10, as the name suggests, it has 10 classes. So plane, car, bird, so on till ship and truck. So this is what we will be using to create the the classes, and because with which we will be able to train. Now in the model, here we are using a ResNet 50 model. So I'm creating a net, and the ResNet 50 will initialize my model. The ResNet 50 is the standard ResNet 50 from its from the paper. And if it's GPU enabled, then we are parallelizing the data so that it becomes much faster to train. And coming to this criterion, so you will see that there is an NN dot cross entropy loss, which is the BCE loss, or the binary or the cross entropy loss, and we have the optimizer, the Adam optimizer, and we have an approx criterion. This approx criterion is what we will be using, and this is basically the CE loss with PSO. Coming to here, you will see that it has a forward method and a backward method. So in a neural network setting, you have a forward pass where you just go through all the layers and keep applying cross entropy loss between your y and the y predicted. And then you have a backward loss, where in backward, where you there's a back propagation that goes in, and you do an auto gradient that most frameworks use. But here we will try to replace the backward with our own approximated gradients. Now coming to the train part, so if you see that the train runs for 200 epochs, and the training is given, and we run for each epoch. Now coming to the train method, what it does is it initializes the model, and it says that okay, it's ready for training. So we go for each batch index. So we have 125. Let's say we have 1,000. So 1,000 by 125. Those will be the number of batches we'll have to run per epoch. So we will get the inputs and the targets. So inputs are nothing but what are the features we want to feed into our model, and the targets is what we get. So it will be a classification model. So we will get a vector of 10 since we have 10 classes. Now coming to the PSO, so I'm initializing the SOM optimizer with the batch size. So this is going to tell us that okay, particle 1 is going to have 125, particle 2 is going to have 125 till particle 100, because the swarm size is 100 as defined. And then we pass the 10. 10 is basically the number of classes, so that it gives back a particle with 10 values, and then you have a target. So what this target will do is this will help us finding the G best essentially. and it is also used in the fitness function. So we optimize the fitness function, and I'm running it for 30 iterations. So running running it for one iteration into 30. So that will give me the C1 and the C1 R1, C2 R2, which is the average of the 30 iterations that I've run, and the G best that I've run after 30 iterations. Now, what we get is that we make the optimizer to zero gradient. So right now the optimizer at zero is at zero gradient. So we are using Adam. So we're emulating Adam and just replacing the gradient with our own gradient. And then we have the outputs, which will give us which you run the model on your inputs and you get the outputs. And this is essentially your predicted values, which you have to make it lesser so that your training is better. Now here gbest is clamped between 0 and 1 because it's a categorical loss, so that's why you have to clamp it within 0 and 1. So right now we are running it on approx criterion. Approx criterion is the CE loss with PSO, so you're passing outputs and targets and the sum CR, the C1R1 plus C2R2, the eta, which is the learning rate, and the gbest value. So here, if you see, coming to the forward pass, it takes these ypred, some CR, ETA, and gbest, which are then stored. So we are storing these for the backward pass. We are storing these values as well in the context, and we are just returning the cross entropy between y and ypred. Now, when we go into optimizer.step, so if you see that I said that we have two starting methods. So when we do loss.backward, it after doing a forward pass, it then does the backward propagation, and in the backward propagation we get the saved tensors. So I have saved those tensors for the backward loss. We get the y and ypred. We also get the sum CR and the eta, which is the learning rate, and then I apply the method, the approximation formula, which is minus C1R1 plus C2R2 divided by eta into gbest minus y. So once we get that, we send this value to the grad input, which is then gives us the gradient, and which can be then used to step into the forward pass and then does the back propagation, which happens by the PyTorch framework. And after that, we get the loss, and we print out the losses, the outputs, and the accuracy here. So we check how much is correct divided by the total, and that gives us an accuracy. This is about it from AdaSwarm. If there are any questions, please let me know.